Hey guys, in this video we're looking at the free response question number 5 from the 2010 exam. So we're comparing two different stores that are selling fish that have identical species of adult tropical fish. So we're looking at the Buy Right Pets and the Fish Friends. Now we're curious to see if the lengths of the fish are significant in any way. So they've randomly collected 8 samples from Buy Right and 10 from Fish Friends. We collect the mean and the standard deviation of them, and then we're asked, do the data provide convincing evidence that the mean length of the adult fish of the species from Fish Friends is greater than the mean length of the adult fish of the same species from Buy Right Pets? So when we see this setup, we're basically being asked to perform a hypothesis test. So it's up to us to determine what type of test it is and how to do it. So let's first look at the intent of this question from the AP exam rubric. So the intent of this question, the primary goal of the question was to assess the student's ability to set up, perform, and interpret the results of a significance test. More specific goals were to assess students' ability to state the appropriate hypothesis, identify the name of an appropriate statistical test and check appropriate assumptions or conditions, compute the appropriate test statistic and p-value, draw an appropriate conclusion with justification in the context of this study. So 1, 2, 3, and 4 are the breakdown of this question. So that's going to basically tell us what sections we're looking at here. So the College Board answer key first, for step 1 is to state a correct pair of hypotheses. So basically, depending on what we call it, we have mu, because this is talking about a mean length. So I automatically know it's a t-test. So that means we're talking about the true mean proportion. So we're using mu in our hypothesis, our null and our alternative. So we can let mu of B represent the mean length of the adult fish of the species from Buy Right, and mu of F represent the population mean length of adult fish of the species from Fish Friends. Remember, we like to say the true mean versus the population. Either way is fine. But then we also have to state the null and the alternative. Okay, and you could also have set it up a little bit differently. Like you could say mu of B minus mu of F is equal to 0. Also, if you had the same equals as your null, you could have switched around and said mu of F is greater than mu of B. As long as it's still equivalent at the end, that's totally fine. Now, what has to happen is you have to recognize this is a 2-sample T. So we talked about why it was T. Also know why it's not matched pair. One easy way to tell here is the sample sizes aren't the same. Remember, matched pair is taking something and pairing it by something. So if you have 2 different sample sizes, there's not going to be an equal amount of pairs. So we know it's 2-sample, and those are 2 independent groups of each other. Really, to tell is whether the groups are independent or not. So since we're comparing 2 different stores and 2 independent groups, that's why it's a 2-sample t-test. Now, for the second step, we have to state that 2-sample t-test, and then we have to check the proper conditions. So for us, we usually refer back to written. So it's RIITNN. So we have to make sure we mention random. We want to say that it's plausible that the independence of the 2 fish stores is there. And then we have 2 independent groups. That's something we definitely have to specify. And T is our 10% condition. So 8 or 10 or both is less than 10% of all fish. And then NN is our nearly normal. So remember, we think about this as if it said that it was approximately normal, we wouldn't have to do anything else. We could just state that. If either or both were greater than 30, then we'd be okay also by the central limit theorem. But unfortunately, we didn't have either of those things, so we have to calculate the picture. So remember, you should have plugged this data into your calculator with your 2 lists, and then you would have went into data and spreadsheets and actually saw the picture, but you have to make sure that sketch is there. You could do it on the same picture if you'd like, how they did F and B on the side, or you could do 2 separate pictures just to not confuse yourself. Then for step 3, we're demonstrating the correct mechanics, including the value of the test statistic, the degrees of freedom, and the p-value. So you're showing those 3 things. Now you can let degrees of freedom be calculated right in the calculator too. And the fourth step is basically making sure that you can understand the data that you collected. So we talk about whether we reject or fail to reject the null, and then we have to make sure there's context in there as well. So again, those key ideas from this question to remember, it's a 2-sample t-test because we have 2 independent samples. Now with our hypothesis, you have to define your parameters. You have to have some context thrown into that mix so that you can, like, your grader can clearly understand that you know what you're doing and how you're subtracting and what's going on. Okay, the think is your conditions. R, I, T, and N we talked about. Now for the show, I would make sure to have a picture, make the sketch. You get the calculation of T. So over here I have the formula for you where it's the T degrees of freedom, the 2 samples subtracted minus 0 over the standard error. In this case, it's the standard deviation of the first one squared over the sample size plus the standard deviation of the second one squared over that sample size. And for degrees of freedom, that would have taken one of 2 things. You could have gotten it right from your calculator because it does that in the test for us, or you could take the smaller sample and subtract 1. So you could have said the degrees of freedom was 7 in this case because my 2 sample sizes were 8 and 10. So you could have done 8 subtract 1. Now for the tell, describe what your p-value tells you. Higher than alpha, we fail to reject. Lower than alpha, we reject the null, but with context, right? We'll always lose points if we don't have the context, so everything we do should have context. And remember, if alpha is not given, we assume that alpha is equal to 0.05. Now, the scoring is broken down into an EPI for each of these steps, 1, 2, 3, and 4. So every essential piece you get is giving you a point towards getting a score of 4. Now, we talked about this in class at times too. We want to show as much work as we can because those partials that we get can lean us up a little bit. So maybe you get 2 partials, but it will round you up. Those are things you want to consider. So that's why we want to be specific with our data. So step 1, remember, essentially correct is just stating your hypothesis and the parameters. There's a couple notes that I would like you guys to look through here attached to the slide, or you could look to the rubric page. It's also on Google Classroom. Step 2, it identifies the correct test by name or formula. So you have to have one of those 2 things in there. Check the independent random samples, check for normality. Now, I want to again reference back to that this is 2010. There's been a lot of changes and updates, especially this year has the new updates. So we have to be sure to make sure independent, we're talking about having 2 independent groups and that the plausible independence is there. We have 2 features of I. Also, the 10% condition, while it's not mentioned here, it is going to be required for this year. So make sure that is something you're ready for as well. So that's why we keep that acronym fresh, like R, I, T, and N. Okay, nearly normal too. We want to make sure we have the right nearly normal situation going on depending on the info we have. Again, look through these notes and kind of see what kind of pieces that you would see that the graders would notice as well. For 3, it's essentially correct if you calculate the t statistic and the p-value. Basically, I'd want you to show the picture there. I'd want you to show the formula. We really want to be given as much detail as we can just to make sure we're covering all of our bases. And again, this one might have been graded a little bit more lenient than the one we might be taking here is. And for 4, it's really essential if we can make a correct conclusion with context, connecting that p-value back. And there's some notes about that and conclusions that the grader could have looked through. So take a chance and look through this slide as well and see that. Generally, like I said, each essential will count as a full point, and a partial will get you half a point. And now, like if say you had 2 E's and 2 partials, now that could be a 3. But if you had 1E and maybe 3 partials, if you have like certain things that are making it show that you're doing a little bit more work, that's the kind of stuff that could bump you up to a 3. So keep that in mind. That's why we have that strict way of doing this, to try to make sure we're getting all the points that we can. So in this next slide, I want to look at student work. So this first example, this got a 4. So they have essentials all the way down. Let's look at what they did. Conduct a 2-sample T test to estimate the true mean difference in fish lengths. So that's given right off the bat. We know what test it's being. We have a correct null and a correct alternative. We mentioned alpha, and then the parameters are set with the mu of F and mu of B. That's a great, clear null and alternative. B members are RIITNN checked. So we have that. They just set it up a little bit differently, but they say independent and random. On 2010, that was enough. Assume both samples less than 10% of the population. So that's our 10% condition. And then we have the 2 pictures clearly showing that they have no apparent outliers, no drastic skewedness. Assume that their distributions are normal, so we can proceed. Okay. Then for part C, our third show, we have a clear use of the formula. We get T, we get our p-value, we have a picture with the shading, and then our explanation's great. With a p-value greater than alpha, we fail to reject the null, cannot conclude that the mean length of the fish from Fish Friends is greater than the mean length of fish from Byrite. Okay, so that's a perfect example right there. A little bit things I would change with the conditions for us, but other than that, great work. In this next one, we have pretty clear and null and alternative again, right? We have the null and alternative shown. We have the parameters stated right next to it. That's good. For part B, though, when we're looking for this second step, they're attempting to check our I, T, and N, but when we check the assumptions, we first assume that the lengths are independent of each other, so that's great. Random samples were taken. We assume that 8 and 10 are less than 10% of the population. And we must assume that the 2 groups of fish are independent of each other. So we've covered our R, I, T, N, or T right there. But then NN, it says the histograms of the 2 groups of fish, each set of data appear to be unimodal and reasonably symmetric. Because the conditions are met, we can go ahead and proceed. But it doesn't really say that we're doing a 2-sample T. So that's something I don't like. And they never gave us a picture. So even though your calculator shows you the picture, the grader doesn't have this picture in front of them. You have to do the picture, whether it's a histogram, whether it's a dot plot, whatever type you decide to show, but you have to have something there. So that only got partial for not having the picture and for that 2-sample T being missing. Now, they did give full credit for these calculations. They showed T, P, and the degrees of freedom. Remember what we just talked about, though. This is 2010. I would not be comfortable doing that. I couldn't say for sure that you would get full credit on this one. I would definitely want you to show the calculation like the previous student and then have the t-value. So plug it into the formula, or at least write out like the different pieces as well. In this case, show me a picture of the normal distribution there with the shading, something. And then for D, students use the phrase retain the null. Okay, we don't really use that phrase. They didn't explain that phrase, so the graders weren't happy there. They do connect the response back to the p-value, which is what saved them to get partial, but they won't get full credit with this retain to null. Remember, we reject or fail to reject, whether it's high or low. And so with an E, and 2 Ps, that ended up being a response grade of 3. Finally, we have this third student. Now, they have a lot of mistakes along the